Hi guys, we're into Unit 2 now. We're starting with Section 7.1. I have two bell work questions here, so these are not in your book, so just if you want, you can write them down on the side, or you can get some scratch paper. It says factor the following. You've done factoring several times in your math career, but it's going to come back up quite a bit in this unit, specifically in Activity 7. So I want you to get some practice before we start using it every day. So go ahead and pause the video and factor questions 1 and 2. So I gave you one where the A term, which is here in front of X, is 1. That's an easier factoring problem, so I'll start you off with some basic ones for today. That's called the A value, the B value is 5, and the C value is negative 36. Down here, A value is 1, B value is negative 3, C value is negative 10. If the A value is 1, it's usually an easier factoring problem. So think of things that multiply to 36. You can ignore the negative for right now. We will check it before we're done to make sure we got that negative taken care of. 3 goes into 36. So right now I'm just putting factors, things that multiply to 36. And you can definitely use your calculator for this. Most of them you won't need to. So of these choices, which one's going to add to 5? 9 and 4 could make 5 if the 4 is negative. And that's where you can also check the negative now because they're going to multiply to negative 36. So one's going to be X minus 4. One factor will be X plus 9. You always redistribute this out, and that is how you can check your answer. Number 2, things that multiply to 10. 1 and 10. 2 and 5. 2 and 5 could get you 3. If the 5 is negative, and again, 2 times negative 3 will give you negative 10. So they're going to multiply to negative 10. And they're going to add to negative 3. You're going to write X plus 2, X minus 5. And you could write these in the opposite order if you wanted to. But the 2 has to be positive and the 5 has to be negative. You can't flip that. All right, now try number 3 before I go over it. So to go through this one, you're still going to do factors of 27. So we have 1 and 27, 3 and 9. But now you have to worry about things that multiply to 2, which is a 2x and a 1x. Before it was just a 1, so it was 1x times 1x, which is why both of these started with x, because x times x is x squared. But here, one of them is going to say 2x, and one of them is going to say x. So we have a couple combinations to try. Let's write 2x, 1x, or just x. Now, most of the times the numbers are close together. That's just the majority of the time how it works out. But that it could be anything. It could be 1 and 27, and sometimes it is. I'm going to try the 3 and the 9. So I'm going to put the 3 first, just because that's the way I ordered it. If that doesn't work, I'll flip it, and I'll put the 9 here and the 3 here. So here's what I do to check it. 9 times 2 is going to be 18x. 3 times x is 3x. Well, 18x's and 3x give me 3. No. So I'm going to flip that. I'm going to put the 9 first and then the 3. And now I'm going to check it. So now when I multiply, 2x times 3 is 6x. 9 times x is 9x. Put 6 x's and 9 x's give me negative 3 x's. Yes, if the 9 was negative, so then it's going to go with this here. You don't want to put it on the x, because that's going to give you a negative 2x. You want to put it on the second term. So this one is positive. And I could always check my answer, so let me go ahead and rewrite it over here. 2x minus 9, x plus 3. When I distribute, there's my 2x squared. And I'll do the red ones, because I already did those in this color. That was 6x and negative 9x minus 27. The ones in yellow, I didn't draw over here because they're very easy to see. It's just first term times first term is first term, and last term times last term is last term. But then there's these two terms that go together to make the middle term. So that's why I always do those, not necessarily in red, but that will simplify to my negative 3x, which is what I started with. So I know that these are correct. Don't forget to always look for a GCF. So if this is, let's say I have a problem, 2x squared minus 4x plus 16. Always, they have a 2 in common, so you always want to factor out the GCF first. And then if you can factor further from here, you would do that. Okay, so just some factoring practice before we get into today's lesson, which is 7-1. So let's go ahead and go there. It says, Fence Me In is a business that specializes in building fenced enclosures. One client has purchased 100 feet of fencing to enclose the largest possible rectangular area in her yard. Work with your groups in item 1 through 7. As you share your ideas, be sure to explain your thoughts using precise language and specific detail to help the group members understand your ideas and your reasoning. We're not really going to do that. Number 1, if the width of the rectangular closure is 20 feet, what must be the length? Well, the picture is helpful. So if I have 100 feet total, remember that's perimeter, that's all the sides added up. And I know that the width is 20. So let's say this is width, this is 20, which means this is also 20. Well, that takes care of 40 out of the 100. So 100 feet minus, I've already done 40 feet, leaves me with 60. So each side would have to be then 30. So what is the length? 30 feet is the length. And then it asks the follow-up question, find the area. So remember, the length times the width is 30 times 20, so 600, and it's feet times feet, so feet squared. Number 2, choose several values for the width of the rectangle with a perimeter of 100 feet. Determine the corresponding length and area for each rectangle. It says share your values. We're not going to worry about that right now. Then record the set. You do not have to fill out the whole table. What I want you to do is pick 3 or 4. So you're going to do the same thing we did number 1, except you're going to pick a different width. So don't pick 20, pick a width of 10. Find the length, find the area, then pick a different width, 12. Go ahead and do that. Make up 2 or 3 or 4. Pause the video. Here are a few that the answer key has. So maybe some of these match what you have. Maybe you picked decimals because you can have a 1.5 foot. That's fine. So if you don't have any of these, that's kind of crazy if you didn't pick any of them, but make sure that these make sense to you and go ahead and fill in 1 or 2 more. You'll notice they kind of organized theirs. You could do them in any order, but they went from a small number to a larger number. So they started at 1. They didn't go up by the same amount each time, but they went up to about 45 for the width. Let's say they went to 50. If they had a width of 50, and this has to be 50, how much is that already? That's already 100 feet, and we didn't even have anything here. So we know that 50 is too big. That's why they only went to 45. They could have went up a little higher, just not quite to 50, anything under 50. What is the relationship between the length and the width of a rectangle perimeter with 100 feet? So what do you notice about the relationship between these two numbers, 1 and 49, 5 and 45? What's the relationship between the width and the length? They add to 50 every time. So you can write length plus width equals 50. That should make sense because the length plus the width, another length and width, so another 50, and 50 more is going to give you your 100. Based on your observations, predict if it's possible for a rectangular with a perimeter of 100 feet to have each area. Explain your reason. So go ahead, pause the video, and answer whether you think 400 is a possible area, and so on. So for your answers, maybe you had 400 in your table, which you can see I had right here. So that was possible. Maybe you didn't have a 400, but you still think it is possible because let's say you didn't even have this value. But let's say you had an area of 225 and an area of 600. Don't you think there'd probably be an area of 400 in between there? If I have way below and way above, that it is possible to have 400. So that would make it reasonable to me. Same idea with 500. If it's not in your table, but my table goes up to 600 or 625, it seems like an area of 500 would be possible. And then the next one on the following page says 700. So you can make your guess on that. My table does not go up to 700. The highest my table goes is to 625, and I've got quite a variety here. I know you didn't do that many, but it doesn't go too close to 700. So I'd predict that probably that's not possible. But again, these are just your own predictions. Number 5. Let L represent the length of a rectangle with a perimeter of 100 feet. Write an expression for the width of the rectangle in terms of L. Now to make this easy, let's go back to what we had written in number, oh, I erased it. Number 3, where we said length plus width equals 50. Let's rewrite that because that part already makes sense to us for number 5. Length plus width equals 50. Now let's take this expression and get width by itself. So if I want W by itself, oh no, what do I want? Write an expression for the width of the rectangle in terms of L. So I want width. So I want width by itself, and I want to know what the width is in terms of what the length is. So if I want W by itself, I'm going to subtract L on both sides. That would be 50 minus L. It's the same equation. I just wrote it with a different term by itself. Now we're going to use that for the next part. Express the area, A of L, so the area in terms of the length for a rectangle with a perimeter of 100 feet as a function of its length, L. That just means L is my only variable. Now I'm going to start with another variable because we understand area to be length times width. But this is 2 variables. I have to have one. You can see it has to be L. So L is fine, but I cannot write width. What's another way I can write width? Right there, 50 minus L. That is how I write area with just one variable, even though that's the same thing as taking length times width. Now I've done it with only one variable, which is helpful. I'd rather work with one variable than with 2. Okay, let's go ahead, and it might ask us to do this later, but we can simplify this. Let's write A of L equals, and let's distribute 50L minus L squared. And let's write it in standard form. So our highest power first. We're going to need that later, and it's nice to always write it in standard form. These kind of look like E's. They should look like an L. All right. Number 7, graph the quadratic function. Now, a quadratic function means its highest power is x squared on the coordinate grid. The way I want you to graph this is pick some points. So we've already got a table. Let me flip back. So I'm going to plot the point, not 149, but sorry about the flipping. Notice the labels are length, area. So if I go back, length is 49, area is 49. So I'm going to plot the point 49, 49. And then I'm going to go back and find another point. So go ahead and plot. I'll put my table back up here for a second, pause the video, plot pretty much all those points right now. So when you plot the points, it should look like this. You guys have worked with parabolas before, so you know that it looks like a U shape. In this case, it's an upside down U. So you can go ahead and connect the points. Now use a graphing calculator to graph the quadratic function, A of L. Set your window to the course to correspond to the values on the axis. So go ahead, grab your calculator, and I would like you to type in the function. You can either type it in this way or this way, and go ahead and try to set your window correctly. Make sure when you're typing it in your y equals that you hit this negative, not the minus, so negative x squared, because you can't have an L here, plus 50x. Then my window, if you take a look, it looks like your x-axis goes from 0 to about 50. You can go a little bit farther if you want. So I'm going to go 0 to 55. And the y-axis goes from 0 up to about 800. Again, these are just estimates, so you can see somewhat of a window. And there we go. That looks like what we have. You can also hit second table to look at some values. Now, my table only goes up by 1. There's a way to fix that, but you could at least check some values. Number 9, use the function a of L and your graphs from items 7 and 8 to complete the following. What is the reasonable domain of the function in this situation? Express it as an inequality, interval, and set notation. So this is good practice for before. So my domain, let's do an inequality first. What's the lowest possible x value, which in this case is L value, would be 0. Can I include 0? Can I have a 0 length? No, so don't do this. It can't be exactly 0, but up to 0. And then the highest number that I can have is up to 50. But again, it can't be exactly 50, because if I have 50 and 50, that's 100. That leaves nothing left for the other side. So all the way up until 50, but don't include 50. Don't underline it. We always want to write it as one continuous statement, so that's inequality. Interval would be 0 to 50. It looks like a point. It is not a point. And then set notation is, you could use X or L. I'm going to use L. L's such that L is an element in the real number system, comma. L has to be, I'll just go ahead and write this again. Now, maybe you have a question about the real number system. So can I have decimals? Yes, I can have a length of 5.5. So I don't have to restrict this to just integers. And then this restricts it to not having negatives. So it takes care of that. All right. Over what interval of the domain is the value of the function increasing? Over what interval of the domain is the value of the function decreasing? So this is the entire domain. Over what part of this is it increasing? It sounds like a difficult question. It's very wordy, but it's not if you look at your graph. This is my entire domain, my entire x value, or in this case, L. Is this graph increasing the entire time? No, it's increasing from 0 up until an L of 25. That's what it's asking. Over what interval is it increasing? It's increasing from 0 to 25. So we will answer 0 to 25. Over what interval of the domain is the function decreasing? When is the graph going down? From what L to what L? From 25 on to 50. Again, we're not going to include 25 because it's not increasing or decreasing there. And we're not including 50 because you can't have 50 there. So you're going to say 25 to 50. And this would mean if we were including it, which we are not. So increase, decrease. Number 10, what is the maximum rectangular area, that's the Y value, that can be enclosed by 100 foot of fencing? Justify your answer. Well, let me hop back to this. This was our original table. Now we just picked values. We didn't pick every value, so we can't say 625 is the highest because it's the highest that we picked. We have to make sure that we actually picked all of the values, which would be impossible, but our graph sort of makes that possible. In looking at our graph, you can see the actual highest point without plotting every single point. So it does occur at a length of 25, and the area there is 625. So it is the highest, even though it doesn't always have to appear in your table. Just look at the highest part of your graph. So 625, remember it's feet squared. And 11, what is the reasonable range of A of L in this situation? Express it as inequality interval and set. So let's go back. So we're talking the Y values, or in this case, the A values. What is the lowest height? Or sorry, the lowest area is 0. Can I have a rectangle with an area of 0? No, it wouldn't exist if its area is 0. So we're going to go down to 0, but not include 0. And the highest, don't put 800 just because your graph goes to 800. The highest that this actually goes to was the 625. So 0 to 625. That's inequality, interval. Actually, what's different here is we can have an exact 625. So this should say this. Important here. I cannot have an area of 0, but I can have an area of exactly 625. Which means when I go to interval, what happens? It will look like this. A bracket, because I can include 625, but I can't include 0. Set notation. A area such that my area is an element in the real number system, comma, and then I can just copy that first part. Sometimes you'll see it with a bracket. I think most times it does have a bracket at the end. It's piecewise, it don't always have a bracket at the end, just the beginning. Explain how your answer to item 10 helped you determine the reasonable range. What was our answer to 10? Well, if this was the highest, that helps us determine it. You don't really have to write that out. We're not going to do all of 12, but it does say go back and see if our guesses to these were possible. So was 400, 500, and 700 possible? We guessed based on our table. But now that we have a graph, is 400 possible? Yeah, it's possible with a length of 10 or a length of 40. Is a height of 500 possible? Yeah, it's also possible with 2 different lengths. Is 700 a possible area? No, not because we didn't guess one that had 700, but because our graph actually will never touch 700. A quick thing I want to show you in your calculator. If you go to graph, you can calculate the highest point. So we know it's 625, but if you weren't sure what number it was, here's how you can do it. Hit second, and then up here above trace it says calc, so calculate. Second is this key, and then calculate. We want to calculate the maximum, so go to maximum, hit enter. It'll say left bound, so I need to arrow over to the left of that highest point. That's far enough. Hit enter. It'll say right bound, so now arrow over. Oh, that's way to the right. Just as long as you're to the right of that highest point. Doesn't really matter how far. Try to get close. And then it says, do I want to guess? Nope, I don't want to guess. Enter. And this is that point. The highest maximum point is a length of 25 and an area of 625. Now, I don't know why it says 3 at the end. It should just be a 0. Sometimes your calculators go to several decimal places and they're not actually always accurate out that far, but 25. Okay, so again, that was second, and then it's above trace, it says calculate. Second, calculate maximum. Go to the left, hit enter, go to the right, hit enter. You don't want to guess, so hit enter again. See, now it went slightly below. Again, I don't know why the calculator does it. It just kind of bases it on where you put the left and right bound. But if you get close, your answer will be very, very close. Okay? I believe that's all for today. Yep. So you go ahead and start your homework then.